Okay, so I'm going to make a series of videos to describe how to do the FSAE frame assignment. So let's see, most everyone will start with the file I'll provide with the sketch right here. Let's get this out of the way. So we'll open this up and probably save it as something else right here. So here we go. Here's our sketch, and we're going to open up and do things in Weldments. One important idea all the way is not to try to do too much at once. So do small little models, right? So here's my structural member right here. I think a big old deja vu. Yeah, that's weird. I feel like I've done this before. All right, so here, the one that I picked for the Weldments, you see that I clicked over. I should have pointed out right here is the Weldments. This toolbar. I can't quite remember how I got the toolbar in there, but you don't necessarily have to do that. I think you can come down into Weldments right in there and then click on the structural member right there. So we click on the structural member. And there's a bunch of different ones, and I decided to stick with ANZ. And if you have ANZ, you'll see that there is, I think that it's lowercase, but I think it is aluminum AL round tubing. There's quite a bit of sizes to choose from, several sizes. I think most everything on these cars is made out of 1 inch outside diameter, with like one exception I think they do have available. And I'll show you where you might find that in our notes right here. So in class 3, I'll bring that up. You can see here's the car, and here is the names of these different pieces right there, in case we want to find them. But and you can see here's the basic size. You see they're all 25 millimeters, which is the same thing as 1 inch. If you go to the rules, which I think are down here somewhere, boom, right here at the bottom. Yeah, there it's at the bottom. You can see that they're talking about these various sizes that each of those pieces is supposed to be. And like, for instance, okay, so size D, which is an impact thing right there, that is, that's the 35 millimeter, which is 1.375 outside diameter. But all the other three are 25 millimeters each, or 1 inch outside diameter, and the thickness, you can see size A is the thickest of these 1 inch of 3, so 0.095. So you can pretty much just make everything out of size A, or you can experiment and try to make this correct if you'd like. But we don't really have a size D. We don't have a 1.375. So if we were going to use that, I probably would use a 1.5 instead, right? So if you're going to go back up to the top right here, the one that has to be, let's see where it is. I missed it right here. I see there's this one of them that says size D, and that's a bent upper side impact member. All right, so I don't think we have a bent side impact member, right? The side impact member would be, we're talking about this one right here. So if we're going to make a bent one, this would need to be that size. So I think we can make everything as 25 millimeter, and just for simplicity, I will make it, let's see, this size right here, right? So we could pull that down to, right, where's the, oh, there it is right there. So you see there's the one outside diameter in 0.095. All right, so I'm going to go with that. Oh, I have to, okay, I haven't made the path. All right, so one of the basic ideas in doing this is you kind of have a choice of either to do one at a time, or you can make little loops. But I wouldn't make too many of the loops just make them where it makes sense, if that makes any sense right there. Like that's one loop. You can't really add anything more to this. So just go ahead and accept it. And you might be doing this a lot, so you might consider hitting that and then hitting green, and it accepts it, and we start again. And so I'm going to make this, this is like a main loop right here, right there. So that's like a main loop that you would want. So we'll accept it. And here's another main loop. Right here. All right, and is it gonna accept all these? I think so. Boom, all right, so we made a loop. And like you might want to make this a loop. One of the issues that can come out when you're for other when making some things loop is that they miters the ends and you couldn't trim them. But that's not really anything that matters to us that much, because we're not going to do all the trimming that would be necessary if you were going to really do this. Oops. Let's see. Okay, so I don't know. I might consider doing, making something like along these lines right there. It doesn't really hurt, I don't think, to make that one piece. And the same thing over here with the other side. Rotate it so we can get, it's kind of hard to see it, which is the correct one. And I think it's the bottom one. There you go. And then you could even do this up here too if you want. Boom, boom. Maybe make that. It's not gonna really hurt anything. You're just not gonna be able to trim it off nice and neat that you would want to do if you were going to like take these and export them, and then have somebody make all the little cuts so that they'd be all ready to go and for welding the thing up. You can't make things that aren't joined together into one little group, into a loop. All right. Also, let's see. I'll do some of these right here. Boom. All right. So you get the idea. It'll take a little bit of time to do, but let's see. You can also add some diagonals if you want on your own. Let's see. I think I'll do these individually. Like I said, you have to do some cuts, do some trimming. All right. So, when it comes to the suspension, or the parts that are going to represent the suspension, we're putting that really in there just for our analysis sake. That would be these little triangle areas and the strut right in there. I used another size, really just for graphical representation. You could make an argument about what those should be and how stiff they should be or non-stiff. It's really up to you when you put those in. So I'm going to pause this, and so the video will be less long. Let's see. Pause, and I'll come back, and it will be mostly done. Yeah, that's what I'll do. Okay, so I decided just to go ahead and use the one that I had over there instead of redoing it all the way. I don't know why it would be I would waste my time with that. So you can also add some other diagonals that you want to that. Like look in between here. Doesn't it look like it needs to have a diagonal right in there? I mean, Or maybe it doesn't need to have diagonal. What would the effect of putting in that diagonal? Would it help us? Would it hurt us? Well, it's not going to help with the torsional stiffness, which I'm going to show in the next video, I think. But what we want to do at some point in here is go mass properties. And let's see if I can make this thing bigger right here. And we need a better density because that density isn't correct. The density of steel is 0.284 pounds per cubic inch. So let's see, let's put this guy in here. Override mass, center of mass. No. Maybe like a lot of times all we need to do is come in here and go to material. Let's see, go to material, specify, and just say that it is steel somewhere here. How about plain carbon steel? Boom. And let's see if that will fix our mass properties. Yeah, see 0.28. So now there's just a good estimate right here of how much this weighs. Right here, we say it's 115 pounds. What we want to do after we do an analysis is see if we can reduce that by getting rid of some things, or perhaps by making them smaller, but still we'll reassess before and after, and well, also check and see what the weight is right there, and they have some comment on it. This is pretty much just a mini design experiment that I want you to mess around with the model and see the cause and effect of adding something. Like maybe we would want to put in a diagonal and see how much weight increase, like a diagonal that goes like underneath the driver right there. Will that help? How about a diagonal right along here, right? And keeping in mind these rules right here that specify some things, I'm pretty much everywhere using the larger ones. What's that? Is that the 2.5? But I don't have to everywhere. So you could go back and specify and try to reduce the weight and see what the changes to this will be, or changes to the outcome. So we're looking at two different outcomes. One is going to be the torsional stiffness, and one's going to be the stresses when going around a corner. So that's going to be enough, I think, for this video, and we'll pick it up in the next one.